Have you noticed how lithium-ion batteries, the ones powering our smartphones and electric cars, seem to have been at their peak for a while? Well, the truth is, these incredible batteries, which have brought so many innovations, are kind of hitting their limits. Their energy density, which is basically how much fuel the battery can store, is stuck between 250 and 300 Wh/kg. This means that even with the best versions available on the market, we're starting to realize that we can't make much more progress in terms of electric vehicle range with this technology. It's almost like trying to fill a box that's already maxed out. No matter how much you push, you can't fit anything else in. Now imagine the impact this has on electric cars. The goal is always to have more range, right? After all, no one wants to be on the road wondering where to stop and charge. With the limitation of lithium-ion batteries, the range of EVs gets a bit stuck. It's like driving a car that could go much farther, but simply doesn't have enough room in the tank to do so. Even with improvements in other car components, like more efficient motors or energy recovery systems, the battery remains the core of the issue. And in this case, the heart is beating as fast as it can. The funny thing is, this technology was revolutionary when it first came out, completely changing the way we use electronics and, of course, how we view electric cars. But innovation always demands more, right? We're at a point where lithium-ion batteries, as amazing as they are, can't give that leap we're expecting for the future of EVs. For many experts, we're at a crossroads. Either we find a new energy storage solution, or we begin to accept that today's EVs have a natural limit on their range with the batteries we use today. This all raises a big question. If we've already exhausted the potential of lithium-ion batteries, what comes next? There are various bets on new technologies like solid-state batteries, which promise more safety and a lot more energy per weight. Imagine a battery that could take your electric car nearly 2,000 kilometers without needing to stop for a recharge. It sounds like something out of a futuristic movie, right? But believe it or not, it's closer to becoming reality than we think. Talent New Energy, a Chinese startup, has come up with an innovation that's getting everyone excited. They're developing a solid-state battery with an energy density of 720 Wh/kg, which is far beyond what we have today. To give you an idea, current lithium-ion batteries are around 250 to 300 Wh/kg. So, this new battery practically triples the energy storage capacity. What this means for electric cars is a revolution. With this technology, the range of an EV could reach an incredible 1,240 miles, or about 1,996 kilometers. You could cross an entire country without even thinking about recharging. This solves one of the biggest concerns people have when it comes to electric cars: the fear of running out of charge in the middle of nowhere. It's as if we suddenly had a much larger and more efficient tank, but without the fossil fuels that pollute the environment. And the best part? Solid-state batteries are much safer than lithium-ion ones. They don't run the risk of catching fire or exploding like lithium-ion batteries can, though it's rare. But how does this technology actually work? The main difference between a solid-state battery and a traditional lithium-ion battery lies in the electrolyte, which is the material that carries ions between the battery's poles. In conventional batteries, this material is liquid, which can cause instability, heating, and even risks of explosion. But in solid-state batteries, as the name suggests, this electrolyte is solid, making them much more stable and safe. This also helps increase energy density because the compact design allows more active material to be stored in the same space. This higher density means the same battery can store much more energy, and this changes the game for electric vehicles. The issue of range has always been one of the main barriers to the mass adoption of EVs. After all, no one wants to spend hours stopped at a charging station during a long trip. With a 720 Wh/kg solid-state battery, we're talking about a charge that could last days or even weeks of normal use before needing to stop again. This is a huge leap compared to what we have now. Another advantage of this technology is its durability. Lithium-ion batteries, over time, start to lose their capacity to hold a charge. Anyone who's had a smartphone for a few years knows this well. At first, the battery lasts all day, but after a while, it starts dying before the day is over. This wear and tear also happens in electric cars. Solid-state batteries, on the other hand, have a much longer lifespan. So, in addition to holding more energy and lasting longer between charges, they also withstand time and use better. Now, one thing that always raises an eyebrow when we talk about new technologies is the price, right? Many people wonder, will this be affordable or just another futuristic thing only millionaires can buy? The good news is that, like any technology, as it begins to be produced on a large scale, the cost tends to drop. At first, of course, solid-state batteries will be more expensive, but as more companies adopt this technology and demand grows, prices should become competitive. And considering that these batteries last longer and are more efficient, the cost-benefit ratio ends up being much higher. But the implications of this new battery go beyond electric cars. Imagine the impact this would have on various industries. From electric planes that could travel long distances without needing fossil fuels to smartphones and laptops that last days or even weeks on a single charge. This technology could truly transform the way we use and store energy in almost every aspect of our daily lives. One of the coolest things about solid-state batteries is their safety. You've probably seen news of phones or cars catching fire due to battery issues. This happens because the liquid electrolytes used in conventional batteries are flammable and can overheat. In solid-state batteries, however, the electrolyte is, well, solid, and this greatly reduces the risk of accidents. They are much more stable, meaning that even under stress or high temperatures, the chance of them exploding or catching fire is much lower. This brings enormous peace of mind, especially when talking about electric cars, where safety is a crucial factor. Another point that makes these batteries so special is their durability. The lithium-ion batteries we use today begin to lose performance over time, which means that after a few years of use, they no longer hold a charge as well. Who hasn't dealt with a phone battery dying before the day is over? Well, with solid-state batteries, this wear happens much more slowly. This means they last much longer before starting to lose capacity, which is a huge advantage, especially when we're talking about cars or devices we use intensively every day. And the most impressive thing is the amount of energy these batteries can store. Solid-state batteries have a much higher energy density than lithium-ion ones. This means that with the same size, they can store much more energy. For electric cars, for example, this is a revolution. Imagine being able to drive hundreds or even thousands of kilometers without needing to stop to recharge. With these batteries, vehicle range could take a massive leap forward, putting an end to the fear of running out of power in the middle of a long trip. And if you think this all sounds too good to be true, just wait to see how these batteries will impact areas beyond cars. Anything that relies on portable energy will benefit from this. Think of drones, for example. With solid-state batteries, they could fly much longer without needing to return to base. Even our phones and laptops could last days or even weeks on a single charge, revolutionizing the way we use our electronic devices. The fact that these batteries are more durable also brings an important environmental issue. With a longer lifespan, we will need to replace batteries less frequently, meaning less waste and less electronic trash on the planet. This is crucial in a world increasingly seeking sustainable solutions. Additionally, because they are safer and have a lower risk of catching fire, these batteries make transport and storage much simpler, without requiring as many extra precautions as they do today. Now, the path for this technology to reach the market still has some challenges. Although solid-state batteries are already under development, Producing them on a large scale and economically is a significant hurdle. They are still more expensive to manufacture than lithium-ion batteries, but like any new technology, costs tend to decrease over time as more companies adopt and refine the production process. It's similar to what we saw with electric cars. Initially, they were incredibly expensive, but now they are becoming increasingly affordable. Speaking of adoption, major automotive and technology companies are keeping an eye on these batteries. Automakers like Toyota and Volkswagen are heavily investing in research to integrate this technology into their vehicles as soon as possible. And it's not just them. Startups and tech companies are also competing to see who can first bring a viable and affordable version of solid-state batteries to market. In other words, we are witnessing the beginning of a technological race that promises to completely change the energy landscape. What makes this innovation from Talent New Energy so special is that it's not just about an increase in the amount of stored energy. It's also about a change in how batteries are designed. Solid-state batteries like this one replace the liquid electrolyte with a solid material, which brings several advantages. Not only does this make them safer, significantly reducing the risk of explosion or fire, but it also increases the efficiency of how that energy is used. With this density, we're talking about vehicles that can travel over 1,200 miles on a single charge. That's almost 2,000 kilometers. This is not just a minor improvement. It's a true revolution. And it's not just the range that's being improved. Another strong point is the durability of these batteries. Talent New Energy is focused on ensuring that these new batteries last much longer than the ones we have today. With lithium-ion batteries, after a few years, they no longer hold a charge as well and need to be replaced. But with these new solid-state batteries, wear and tear are much less. This means that even after years of intensive use, like a car running daily, the battery will still maintain a good portion of its capacity. In addition, one thing many people overlook is the impact on charging time. Solid-state batteries have the potential to be charged much faster than conventional ones. And Talent New Energy is exploring exactly that. Just imagine being able to fully charge your electric car in minutes instead of waiting for hours. This not only makes life easier for everyday vehicle users, but it also helps expand the acceptance of EVs, as charging time has always been one of the biggest hurdles for many. The development of this prototype by Talent New Energy also brings hope for greater adoption of electric vehicles in the global market. Many consumers are still hesitant to switch from combustion vehicles to electric ones due to concerns about range, safety, and cost-effectiveness. But with technology like this, where cars could travel long distances on a single charge, combined with the fact that these batteries last much longer and are safer, these obstacles begin to disappear. And of course, we can't forget the environmental side. One of the biggest criticisms of lithium-ion batteries is the environmental impact of lithium and other metal extraction, as well as the disposal of these batteries at the end of their life cycle. With solid-state batteries, in addition to having a longer lifespan, there's the possibility of using fewer harmful materials, making the entire manufacturing and usage process more sustainable. Talent New Energy is focused on this and already has plans to make the production of these batteries more environmentally friendly. Another interesting point is that despite this prototype still being in development, the market is already paying attention. Major electric vehicle manufacturers are forming partnerships and heavily investing in this new technology. After all, who wouldn't want to be the first to offer a car with a battery that lasts much longer, charges faster, and has greater range? This could be the differentiator many brands have been waiting for to dominate the EV market in the coming years. And what does all this mean for the future? Well, if Talent New Energy continues at this pace, it's quite likely that in a few years, we will see these batteries revolutionizing not just electric cars, but also the entire electronics industry. After all, anything that requires a battery could benefit from this technology. Imagine smartphones that last days on a single charge, drones that can fly for hours, and even portable medical equipment that can operate for much longer without needing constant recharging. What's even more interesting is that with a smaller 50 kilowatt-hour battery, the range would still be impressive. We're talking about around 500 miles, which is over 800 kilometers. That's more than enough to meet the daily needs of many people using their cars. Imagine a Model 3 or Model Y covering that distance on a single charge, practically eliminating the constant worry of, will I make it to the charger in time? This means long trips without stress, without having to plan stops for recharging every few hours. This change wouldn't just affect long-distance drivers. It would also open new doors for the use of electric vehicles in more remote areas. Today, one of the biggest challenges to the popularization of EVs is the charging infrastructure. In many places, especially in more distant regions or developing countries, there isn't a reliable network of fast charging stations. But with this new battery technology, the need for frequent charging points would be drastically reduced. Now think about it. If Tesla really incorporates this battery, it would totally change the market. Because it wouldn't just be about range, but also about charging time. With a battery like this, which not only stores more energy, but also charges faster, Tesla cars would become unbeatable. That waiting time of half an hour or more at supercharger stations could drop to just a few minutes. This would make the transition from combustion vehicles to electric ones much more appealing for those who still have concerns about charging time. And there's more. With this impressive range, Tesla could redesign its batteries to be more compact. A smaller 50 kilowatt-hour battery would already cover a good portion of daily needs, allowing the cars to be lighter, more efficient, and perhaps even cheaper. Reducing the size and weight of the batteries could also mean using fewer materials, which perfectly aligns with Tesla's mission to make the world more sustainable. Less consumption of raw materials, and a lower environmental impact in the manufacturing process. Of course, this change wouldn't just be an advantage for consumers, but also a strategic blow to the market. Tesla already dominates the electric vehicle sector, and with this solid-state battery technology, it would be very difficult for other automakers to keep pace. The challenge for competitors would be enormous. They would have to invest in research and development to try to achieve that level of range and efficiency. This could create an even bigger advantage for Tesla in the global market. Moreover, the adoption of these solid-state batteries could change how we think about luxury electric vehicles. Models like the Tesla Model S Plaid, which are already benchmarks in performance and technology, could reach a new level of exclusivity. Imagine a luxury car that not only has breathtaking performance, but can also travel nearly 1,000 miles without needing a recharge. This would create a new driving experience where range and performance combine perfectly. And we can't forget the positive impact on freight transport. With this new technology, electric trucks like the Tesla Semi could travel immense distances, which is a game changer for logistics. Companies that rely on long-distance transport would save a lot on fuel. And with the capability for fast charging, downtime on the roads would be minimized. This would represent a revolution not only in passenger transport, but also throughout the supply chain. Imagine how incredible it would be to arrive at a charging station, plug in your electric car, and in just 15 minutes, have it ready with 80% charge. This is exactly what solid-state batteries promise to deliver. The key trick behind this is the high ionic conductivity that solid electrolytes possess. These electrolytes allow ions to move much faster within the battery, resulting in significantly shorter charging times compared to traditional lithium-ion batteries. Now think about it. 15 minutes is just enough time to stop at a station, grab a quick coffee, and stretch your legs. This practically eliminates the anxiety of waiting an eternity to charge your car on long trips. Today, even with Tesla superchargers, you still need to wait about 30 minutes to charge to 80%. It may not seem like much, but in a busy routine or during a long journey, every minute counts. With this new technology, even the idea of stopping to charge your car during a trip could turn into a pleasant break instead of an inconvenience. And the coolest part is that this technology doesn't require the battery to be huge to work. Even smaller batteries could benefit from these advantages, meaning that more compact and affordable cars would also have access to super fast charging. This would change people's perception of electric vehicles, making them even more practical and viable for everyday use. The transition from combustion engines to electric ones would become increasingly easier, as the main concerns people have about EVs, like charging time, would be resolved. What's even more interesting is that this advancement comes from a structural change in the battery. Instead of using liquid electrolytes, like in lithium-ion batteries, these new solid-state batteries utilize a solid material that facilitates the movement of ions. This not only speeds up charging, but also makes the battery safer. Without the risk of leaking flammable liquids, the chances of accidents like fires or explosions are drastically reduced. So, in addition to charging faster, you're driving with much greater safety. And of course, this technology would also open up new opportunities for innovation in other sectors. Think about mobile devices, for example. With solid-state batteries, the same principle of fast charging could be applied to smartphones, laptops, and even portable medical devices. Everything could be charged in a fraction of the time we're used to, completely changing how we interact with technology in our daily lives. We would never have to worry about being stuck at a power outlet for too long again. But returning to vehicles, the impact of this revolution in charging times would also directly affect the driving experience of autonomous cars, like Tesla's Robotaxi project. Imagine a fleet of robot axes that can quickly recharge between rides, maximizing efficiency and reducing downtime. This would make the service more accessible and available, which in turn would accelerate the transition to mass autonomous transport. It's the kind of technology that makes the entire system work better. Finally, we must consider the impact this would have on the electric vehicle market as a whole. If Tesla or any other company adopts this solid-state battery technology with such short charging times, the competition will heat up. Other automakers will have to scramble to develop similar technologies or risk falling behind. This could give a new boost to innovation, not just in terms of batteries, but throughout the entire electric vehicle production chain.